Russian refineries, hundreds of kilometers from the front, now burn from Ukrainian drone strikes. These attacks did not begin with grand announcements or clear red lines. They started as experiments using small commercial-style quadcopters near the front. Ukrainian soldiers strapped explosives to simple drones and learned through trial and error. Out of these field tests grew a new long-range strike capability. The core idea behind the campaign is straightforward. Russia funds its war with oil and fuel exports. Oil refineries, depots, and transfer terminals turn crude oil into usable products. Destroying or disrupting these sites weakens logistics and reduces export income. Long-range drones offer a way to reach those targets deep inside Russia. Ukraine faced a basic problem at the start. Western partners were reluctant to allow their weapons to strike targets inside Russian territory. Long-range missiles were scarce and politically sensitive. Ukraine needed a tool that did not depend fully on outside approvals. Indigenous long-range drones offered a politically flexible alternative. Ukrainian engineers and small firms began designing new unmanned aircraft. They focused on range, cost, and simplicity rather than perfection. Many designs resemble small light aircraft with propellers and straight wings. They often use commercially available components where possible to lower costs. The key requirement is reaching several hundred kilometers with a useful warhead. Most long-range Ukrainian drones are slow compared with missiles. They fly at subsonic speeds and at relatively low altitudes. However, they are cheap enough to be used in swarms or repeated attempts. Russia must spend more expensive air defense missiles trying to stop them. Over time, this exchange favors the cheaper platform if it keeps improving. Guidance is the next crucial element. Ukrainian long-range drones typically use satellite navigation for mid-course flight. They may combine this with inertial systems that track motion without external signals. Some use pre-programmed routes that follow waypoints around strong defenses. Others may use terrain data or visual guidance near the target to improve accuracy. Ukraine also adapted to Russia blocking satellite navigation signals. Engineers upgraded navigation systems to be more resilient against jamming. Drones can carry multiple navigation antennas and frequency options. Some designs can continue toward the target using inertial guidance once they lose external signals. This reduces accuracy, but still threatens large refinery complexes. The choice of targets reflects both strategy and practicality. Refineries are large fixed facilities with tanks, towers, and processing units. Even a drone with modest accuracy can hit something valuable. Fires and secondary explosions can cause far more damage than the initial blast. Repairing damaged refining units takes time, specialized equipment, and skilled workers. Ukraine initially focused on refineries near the border regions. These were easier to reach with early drone models. As confidence and range increased, strikes pushed deeper into Russia. Facilities near St. Petersburg, the Volga region, and central Russia came under attack. Each new reach demonstrated growing technical capability. Russian air defenses faced a difficult challenge. Their systems were designed primarily for fast aircraft and ballistic missiles. Slow, small drones present a different profile and can fly at low altitude. Radar detection is harder, especially against ground clutter. To protect distant refineries, Russia has had to reposition air defense units away from the front. Moving air defenses deep into Russia has trade-offs. Systems guarding refineries are not protecting Russian troops at the front. Ukraine benefits when Russian air defenses are spread thinner along the battlefield. The drone campaign, therefore, has indirect military effects beyond the immediate fuel damage. It shapes Russian resource allocation. The economic impact appears in several ways. Damaged refineries must reduce or halt operations during repairs. Russia then has to reroute crude oil to other facilities or export more unprocessed crude. Domestic fuel supplies sometimes tight, raising internal prices in certain regions. Export volumes and product mixes can change, affecting foreign revenue. Oil markets notice even small shifts in Russian exports. Refined product exports such as diesel and gasoline can drop after major strikes. Russia has occasionally imposed temporary export restrictions to stabilize domestic supplies. These moves influence global fuel prices, especially in Europe and nearby regions. Ukrainian drones therefore exert pressure beyond the battlefield. Ukraine selects targets with some care to manage political risk. Attacks have focused overwhelmingly on military-related or dual-use energy facilities. Sites that clearly support Russian logistics or export income receive priority. Ukraine usually avoids civilian infrastructure far from war support functions. This approach aims to preserve international backing. Legally and diplomatically, Ukraine argues these attacks are self-defense. International law allows striking military objectives on an aggressor's territory. Energy facilities that fund or fuel the invasion qualify as such objectives. Many Western governments quietly accept this logic while remaining cautious in public statements. Some draw distinctions between using Ukrainian weapons and using Western-supplied weapons. The production side inside Ukraine is also evolving. Defense firms, startups, and volunteer groups all contribute to drone development. Assembly lines produce airframes, electronics, and engines at growing scale. Some components come from foreign suppliers, others from domestic workshops. Redundancy matters because Russian strikes target Ukrainian industry. Ukraine does not publish detailed specifications for obvious reasons. However, open sources and debris photos reveal patterns. Typical long-range drones carry warheads large enough to significantly damage processing units or storage tanks. They often launch from well behind the front, far from Russian artillery range. Ground crews require relatively simple equipment, such as catapults or short improvised runways. Russian countermeasures continue to adapt as well. In addition to air defenses, Russia uses smoke systems to obscure refineries. Large smoke generators can hide critical units from visual and infrared guidance. Additional fencing, blast walls, and dispersion of storage reduce vulnerability. Yet Ukraine responds by increasing the number of drones per attack to overwhelm defenses. Electronic warfare is another Russian tool. Jamming stations attempt to disrupt satellite navigation signals across wide areas. Some drones lose accuracy or crash when jammed. Ukrainian designs therefore add anti-jamming features and backup navigation modes. The contest resembles a continual software and hardware duel in real time. Operational planning matters as much as engineering. Ukrainian intelligence maps Russian energy infrastructure in detail. Satellite imagery tracks repair progress and capacity reductions. Social media and local reports sometimes reveal fires, closures, or fuel shortages. This information helps planners assess which sites remain weakened and which have recovered. Ukraine also studies the structure of Russia's fuel distribution network. Pipelines connect fields, refineries, storage, and export terminals. Railway lines move fuel to military bases and civilian markets. By understanding bottlenecks, Ukraine can pick targets that create cascading effects. A single damaged junction can disrupt flows across several regions. The drone campaign aims for cumulative strain, not instant collapse. Each individual strike may only degrade one facility for weeks or months. Over time, repeated hits force Russia to choose between repairing, relocating, and upgrading defenses. Maintenance crews become overstretched and spare parts scarcer. Strategic resilience erodes slowly but steadily. There are limits to what drones alone can achieve. Russia still produces large volumes of oil and fuel. Many refineries sit deep inside the country, heavily defended and redundant. Completely shutting down Russian exports would require far more sustained damage. Ukraine instead focuses on raising costs, complicating planning, and reducing flexibility. The psychological dimension is significant. Russian citizens far from the front see or hear about fires at refineries. The perception that the war reaches deep into Russia can influence public opinion. Regional authorities must respond to emergencies and explain repeated incidents. The aura of safety inside Russian territory weakens with each successful strike. For Ukraine, long-range drones help offset disadvantages in conventional missiles and aircraft. They cannot substitute for a full air force, but they open new strategic options. Drones enable harassment of critical infrastructure while preserving scarce missile stocks. They also signal technological competence and domestic innovation capacity. This can attract foreign investment and partnerships. Over the coming years, both sides will keep improving. Ukraine will seek longer range, better guidance, and higher reliability. Russia will refine detection networks, electronic warfare, and physical protection. The contest around oil infrastructure will likely remain very active. Its outcome will influence both battlefield operations and wider economic strength. Want to learn more? Visit Superlore.ai and create a custom episode on any topic you wish. Try it for free today and unleash your curiosity.